When your website goes down, it can be super stressful, and without the right infrastructure and tooling and processes in place, you might not be able to identify what caused the issue. And this can lead to a highly distressing situation, especially if no one's taking ownership. But there is a series of tactics that can get you to stable, stress-free web services. We know this because we've done it multiple times, and once you get there, it's a breath of fresh air because you achieve a sort of equilibrium or status quo where it's easy to detect, identify, and even preempt issues before they occur. And I'm going to talk about a few of these tactics today. Alright, so first up is getting your site live quickly without any hiccups. Enter the world of CI/CD, or continuous integration and continuous deployment, which is like having a magic wand that automatically tests and deploys your code. You want to make sure that you include tests for any key things you're concerned about, such as functionality, security, accessibility, page speed, scalability, or load testing. This will catch a whole bunch of things that will lead you to have to do additional releases, and additional releases increase the risk of downtime, and they can catch any of those items which might lead to that downtime. Because it's automated, it speeds things up, and you don't get any human error in the deployment process. When you get to an advanced stage, you can start thinking about blue-green or canary releases, which can make it easy to test changes and roll back if needed. The second thing we'd look at is exploring containerization with Docker and orchestration with Kubernetes. So Docker containers are like a resource-efficient wrapper around your application's environment, ensuring consistency across development and production. So there's no more of that, well, it's working on my local machine moments with the developer, right? Kubernetes orchestrates these containers, managing the scalability and fault tolerance. But for certain applications, you might want to consider a serverless architecture like Google's Cloud Run, Cloud Functions, or App Engine, or Azure's App Service, which allow you to focus on the code rather than infrastructure management, while still offering scalability and cost effectiveness. Next, we turn to page speed optimization, which is a critical factor in user experience and search engine ranking. To optimize effectively, we would focus on things such as compressing and properly formatting images, implementing efficient caching strategies, and minimizing the number of HTTP requests a page makes. Utilizing asynchronous loading for JavaScript and CSS files can also enhance your loading times, as can leveraging the capabilities of content delivery networks such as Cloudflare. To go with that, the fourth thing we'd look at is optimizing resources. So resource optimization is a multifaceted challenge. It encompasses server-side efficiencies, front-end optimizations, and database performance tuning. Key steps for this would include optimizing server response times, implementing lazy loading for images and scripts, and ensuring efficient database indexing and query execution. And right-sizing your cloud resources will help you be more cost-efficient, freeing up your spend for other areas. Remember that optimal resource utilization directly correlates with improved user experience and reduced operational costs, because your server isn't having to process as many bytes, so the pages are faster for the user, and you don't need as much server resource. The fifth item we'd look at is monitoring DORA metrics. So monitoring DevOps research and assessment, or DORA metrics, is crucial for gauging the effectiveness of your development practices. So we'd focus on things like the deployment frequency, the change lead time, the change failure rate, and the mean time to recovery as key metrics to look at. Additionally, we'd look at understanding and optimizing the user's critical path on your website. We'd look to employ user journey analytics to identify and streamline any key interactions that they're making on your site. And of course, we don't want to leave out support, which is our sixth item. So all websites have issues at some point, and the key thing is how effectively you deal with them. So this is where having a site reliability engineering team and a 24/7 on-call support team can help you get back up and running. The important thing here is that they should work to a service level agreement, which states how quickly they'll respond to issues depending on the issue severity. So let me take a moment to mention that if you are having problems with your cloud infrastructure, or you're aiming to save on your cloud costs, or looking to move to the cloud, then head over to firney.com/review to get a free review of your cloud or hosting to see if we can help you optimize your cloud hosting services. We've managed to get some great discounts with Google, AWS, and Azure, so we can get you discounts against the list price for cloud services on those platforms. And we can also provide free support as a part of that agreement. So visit firney.com/review and drop in your details, and we'll have a chat to discuss how we can help. So back to our list, the seventh item we would look at is fault-tolerant code. So defensive coding is essential for building resilient web applications, and you need to implement strategies such as circuit breakers or exponential backoff in your API error handling and retry mechanism. This approach is particularly crucial in microservice architectures, where inter-service communication is key. Your code should gracefully handle unexpected failures to maintain a consistent user experience. The eighth item we'd look at is well-structured and well-documented code. Well-structured and documented code is the backbone of maintainable and scalable web applications. The easy way to employ this is to pick a public coding standard and stick to it throughout the whole team. Emphasize clean coding practices, adherence to design patterns, and comprehensive documentation, and use linters to help you maintain consistency. This helps not only facilitate future maintenance, but also streamlines the onboarding process for new developers. Regular code reviews and refactoring sessions are also key in maintaining code quality as well. The ninth item we'd look at is the application architecture we want to use. Choosing the right architecture is a pivotal decision in any project. Microservices offer scalability and flexibility, but come with the complexity of distributed systems management. Whereas monolithic architectures, while simpler and more straightforward, can become cumbersome as your application grows. So your choice should be guided by your project size, team expertise, and scalability requirements. And there's also a halfway house where you deploy a micro monolith, which is where you build a monolith architecture, but you use patterns from microservices architecture in that monolith. So you might have different entry points into your application, and you might separate each part of codes for later deployment into microservices. So building a reliable website is a comprehensive process that requires a thoughtful approach to your development practices and architecture choices and performance optimization. There's loads more you can do, but by following these best practices, you can ensure your website not only meets but exceeds the expectations of your users and your stakeholders.